All right. Hello. So thanks everybody for coming to this presentation. Thank you 44Con for suggesting that we come and talk about our project. So I'm going to be talking about our efforts at adding security features to a Linux desktop. A lot of them are things you guys probably are aware of, but our goals include making things easier for people to use. So we are a group of kind of old school security people. We come from like security focus, core, if you guys remember core impact. So we have a lot of background in offensive security and in the vulnerability research and exploit world. We're currently working on usable security tools. We're working on defensive technology, and we have an open source project called Subgraph OS, which some of you might be aware of. That we released an early version of last year. So I'm talking about that. This is a tentative logo. It looks like a flying fist. It's supposed to be a cuttlefish, but it's not very good at looking like that. So it's still a work in progress. But that's our animal, I guess, that represents our project. It's a clever relative of the octopus or squid that is very good at hiding. So this is kind of a conceptual diagram of our project. It's a little bit out of date, but maybe some of you have seen it before. Basically, the idea is we run, we have a hardened kernel, and we run applications, exposed applications in sandboxes, and we offer control over the runtimes of those sandboxes, including how they leave what their network exit is. We originally received support for this project from the Open Technology Fund, which is a U.S. government fund for internet freedom and censorship circumvention projects. So we had a heavy emphasis on building something that supported Tor, but that's changing, and that's something else I'll be talking about and hopefully giving a demo of. So yeah, we came up with this term for the area of work we're working in, and we called it adversary resistant computing. And what that means for us right now is resistance to network-borne targeted attacks. So this is the traditional kind of scenario where client programs or desktop software is exploited by things that come from the internet. So email attachments, website content, things like that. So why did we start the project? Well, we've all been running Linux or, I don't know, OpenBSD maybe in the past or FreeBSD as desktop machines for a long time. And we've all come up with our own ways to harden our own endpoints as individuals. But we really wanted a nice kind of like Ubuntu with GR security. Like this nobody's ever done this before. So that was really where it started. And we couldn't believe that people out there were using things like Tor browser or other applications without even the most basic mitigations. And we know the people who make Tails, some of them, or who work on Tails, and we like them or respect them, but we just doing this was outside of their area of expertise, perhaps, and it wasn't on their horizons, on their roadmap. So, originally we thought, okay, well, we'll just, we at Subgraph were doing other things. We thought we will just maintain a patched kernel and let other people use that because we wanted it for ourselves, and we thought we could make that available. But then as we thought more and more about this, we just realized there's like so much more we could do and want to do, and thus began our project. So the high-level goals are to, like everyone else these days working in the defensive area of security, is to raise the cost to the adversary. The way you do that is you prevent exploits from being successful in the first place. That's with exploit mitigations. You detect attempts to exploit and failed attempts so that you hopefully burn exploits. And if an exploit against the process is successful, you try to contain the impact so that the rest of the system is minimally affected and you can prevent persistence implantation. So these are like our big security goals. We also want to make security tools easier to use. So a hardened kernel was a thing of, was a privilege for system administrators who were able to deal with it, or power users or security geeks. Sandboxing applications, there are a few options available in the Linux world. We had our own ideas for how to do it, and we think we have some advantages in our approach, which I'll talk about. Also, being notified of suspicious events. So many things happen on a computer, especially like an endpoint, like a desktop computer that's not managed in an enterprise environment, by a security organization. Events happen that maybe the user should be made aware of, and they just get rotated away and then they disappear. So we wanted to make all of these things more accessible, build them in, and that's what we're working on. It's a long-term project. So our kernel includes, today, since GR Security is now exclusively a commercial product, we're using a forward port of the last free public patch set. It's being maintained by that person. Before they started releasing patches, we had evaluated forward porting the last patch ourselves, and we had started doing it, but he's doing it, so we're just using his patch. And if you are unaware that that's available, you should check it out. It's a really nice thing that is being done there. So that includes GR Security, PAX, and WRAP. We offer userland management built in for maintaining PAX flags on binaries, even across updates. We have a kernel. The kernel that comes with Subgraph OS is reduced, so we remove weird drivers, like drivers and things that we think people are unlikely to use, exotic drivers. We try to. This is a goal of ours. It's an ongoing process to reduce all the bloat that's in the kernel, because that's just more attack surface. Kernel events that are interesting, especially kernel events that are reported by GR Security, we try to capture those and report them to the user. And we try to take advantage of other features in GR Security, and there are many. But one noteworthy example is deny new USB, which we use to optionally lock the USB port while the desktop screen is locked. We wrote a little utility that monitors the state of the desktop and locks the USB ports when the desktop is locked. Another thing we did is our sandbox. So the sandbox uses Linux kernel isolation primitives, the same ones Docker uses, so namespaces, things like that. We run sensitive applications in sandboxes, so browser, PDF viewer, chat clients, mail clients, and this offers per sandbox control over how these things do or don't leave the network. So you can create a sandbox that has no network at all. For example, PDF viewer, LibreOffice, those are examples of such default configurations. We have sandboxes that can just go out over a SOCKS 5 port and no other network access. We support OpenVPN. We have a prototyped implementation for WireGuard that's not available yet, but it works. So you can also clone profiles, so you can have like Chromium profile that's like for ClearNet, one that's totally stateless, or one that's for OpenVPN, et cetera, et cetera. We have BitTorrent sandboxed as well over OpenVPN. Firewall, so this is something that a lot of people seem to like. We have something like Little Snitch, if you've ever heard of it. So I see some heads nodding, okay, good. So we have a per app firewall that is also SOCKS 5 proxy aware. That's new, which I can demo. And that just alerts you if applications are attempting to connect to the network and tells you what the nature of the connection is. Shows you what process it is, shows you what UID, GID, et cetera. So by doing some of the things in the red column, we're addressing the things in the red column with the things in the green column. I don't need to read this slide to you, but these are some of the things we're doing. to raise the cost to the adversary. Although it's still an early project. So yeah, I've already talked about this, but preventing attacks from being successful in the first place, we use exploit mitigation, we use PAX and GR security for that. Containment comes from our sandbox, so removing all the rest of the data on the file system from the sandbox. So if the sandbox application is compromised, there's not much interesting data to be removed. And just better detection of failed exploit attempts. That is itself so useful and has some strategic value. So why is exploit mitigation important? I don't really need to tell you people that, but you can't patch every vulnerability. You have to assume that there are an infinite, in some applications, basically an infinite number of vulnerabilities that can be found and exploited. So the idea is to tackle entire classes of vulnerabilities. PAX is an early innovator and inventor, PyPatch, and his PAX patches are like, this guy invented basically modern exploit mitigation. The address space layout randomization in PAX was way ahead of its time, and everybody now is just getting caught up, except sadly, the Linux kernel still to date is kind of very weak compared to the modern commercial operating systems. But yeah, that's an important mitigation that we include, of course. To address ROP, the GR security team released a public demo version of the Linux kernel like the Linux kernel patched and compiled with ROP, or patched to be compiled with ROP. So ROP is a control flow integrity set of it's a control flow integrity system that prevents ROP chains from being constructible, really, by doing forward and backward validation on returns and function pointers being called. So that is a huge protection for the Linux kernel, and we're really excited about that. And it's really neat that when you get that in the Linux kernel, it extends to KVM, it extends across the whole Linux kernel, providing very, very strong mitigation against local privilege escalation. So we just get that with the last free public GR security PAX patch set, which is amazing. This is a commercial product that they offer for, I saw them tweet that it's available for Zen, which is pretty exciting, I'm sure, if you're a cloud provider, considering the recent, like all the recent vulnerabilities published for Zen. We write a lot, pretty much all of our applications in Golang. Golang offers resistance to memory corruption. And I mean, so do languages like, compiles natively, it has lots of advantages. You could say that about like Python too, but Python uses a lot of C libraries and just wraps them, whereas Golang is like Java, where a lot of the total Golang library all the way down is all in Golang. So if you use like TLS in Golang, that's all native Go, whereas if you use TLS in Python, you're using OpenSSL under Python, like under Python wrapper. So this is, it's a really fun language to program in and offers reasonable system-level exposure. You can write some cool stuff in Golang, although we run into some problems, which I can, if anyone wants to talk after this about dealing with low-level things in Golang, I have a few examples of problems we've run into. We've replaced certain applications entirely, so Pigeon, for example, and everything based on libpurple, we just tossed it because it's not really salvageable. And some of our friends at ThoughtWorks have written a new OTR XMPP client called Koi, and they've written it in native Golang. And we've contributed some code to it, and it's not bad to use, actually. It's pretty nice, considering how new it is. So that's an example of an application we just tossed and replaced with something new entirely. Hopefully we can do this with Mail client, because Thunderbird is kind of scary. That's a screenshot of Koi. Yeah, so more GR security stuff, like addressing privilege escalation. GR security does so many things, especially if you're using chroot. The USB protection I mentioned, it does like exploit brute force prevention. So if something seg faults repeatedly, GR security will block execs. Just understanding those events as like brute force exploitation attempt, randomized identifiers throughout the system, things like that. One interesting thing I want to talk about is how GR security removed support for unprivileged user namespaces entirely from the Linux kernel. And we of course, totally agree with that. Anyone here familiar with unprivileged user namespaces? They're used in, anyone not familiar? Okay, so they're used in Docker. They're a feature for containers where you can create a new UID namespace, and to do that as an unprivileged user means that you can get a UID 0 process in another user namespace without being UID 0 in the outside namespace, in the original namespace. This is problematic because there's a whole lot of kernel attack surface exposed that was assumed to be only reachable by a UID process, a UID 0 process. So like as a result of this, this code that has been scrutinized and audited less has been found, of course, to be vulnerable to many vulnerabilities, and probably many in the future. I've just got 3 recent examples of kernel privilege escalations that are related to that are exposed, that are possible because of unprivileged user namespaces. So if you pick one of these and if you look at the code, you'll see that the exploit sets up a sandbox to give the process a kind of fake a namespace UID 0, and then it can do the setsock opt option that you need to be root to do to reach the code path and exploit the vulnerability. So the Spender and Pipehatch and the GR security people saw this coming, and they just removed it completely, and as a result, we don't have exposure to that, and neither does anyone else using GR security. So going forward, if an exploit is successful, we want to reduce the impact to the rest of the system. We want to prevent privilege escalation. We want to prevent persistence. How do we do that? We have AppArmor profiles. That's not that exciting because there are other distros that have AppArmor profiles. We've added some of our own. We've AppArmored our own things, but that's part of the story. Oz is our sandbox framework. It's meant for user applications, and it's been designed to systematically remove avenues for privilege escalation. Oz stands for, well, Oz it was just arbitrary, but we called it Obsidian Zebra, but that's not why we called it that. It's just, as I said, arbitrary. So here's kind of a diagram you can see of how Oz works. Basically, we replace the binary on the file system, or we redirect the path. There's a client called Oz, and when you run your program like events, which is a PDF viewer, you're actually running Oz, the client, which reaches out to a daemon that's running that looks up the Oz profile, and then it spins up an init process in a new PID namespace, in a new network namespace, and then it runs the application with parameters that are defined in the profile. And if seccomp is one of the parameters, a seccomp wrapper will exec the program after installing a seccomp filter. It also sets up networking, and we deal with exposure of the X11 server by using Xpra client, but this is a temporary thing. We're not happy with Xpra, but the point of that is that we separate. It's kind of like a remote desktop sort of arrangement. So the application, like the X client, doesn't have direct exposure to the host X server. We kind of firewall it using Xpra, and that prevents the classic X11 shenanigans like keystroke sniffing or keystroke injection, etc. So So yeah, we have a per application sandbox policy. We use process and network namespaces. We use chroot to isolate the file system. We rebuild /dev inside the container. We do things like blacklist set UID executables from the file system. We have GUI support for like putting files into the sandbox. So if you want to, I don't know, if you open the LibreOffice sandbox, you have no files there. We have a GUI where you can pick the file from outside of the sandbox and you can put it into the sandbox and then it's there to be edited or whatever. Yeah, we use Xpra, if any of you are familiar with that, to isolate the X client from the server. We wrap applications in seccomp BPF, and we can configure various network parameters for each app. So here's a little table of the applications. We support some of them, and these are the privileges that the access to system resources that we configure by default. Right. So for example, I don't know, events gets no network, gets no audio, has a restricted file system, and we whitelist the system calls that are exposed to it. So that's a screenshot of the sandbox manager as it exists today. Seccomp BPF was an exciting area of research for us. It was something I worked on a lot personally. And it was totally experimental for us. So for a user land process, the entry points into kernel land are number one on Linux, number one system calls. And then secondary to that would be interacting with things like procfs, sysfs, and nodes in /dev. These are like primary ways that a user land process interacts with or manipulates. Oh, look at that. That's something I wanted to show you guys. That's our notifier that something blew up and violated its seccomp. Anyways, I wanted to show you guys. I'm glad that happened. Okay. So right at the right time too. I totally didn't plan that. So there are over today in the current Linux kernel, there's over 330 system calls, and if you consider that some of those system calls at least are kind of like multiplex system calls, like ioctl does like so many things. Set sock opt is another complicated system call. The code paths into the kernel are even greater than that. I mean, 330 system calls is not the right way to think about this exposure. Basically, all the privilege escalations today are through vulnerabilities in the kernel that are typically exploited through system call invocations. The days of exploiting some set UID program that actually comes with a modern Linux distribution, I think it still happens from time to time, but it's far more common that privilege escalation is through kernel vulnerabilities. So what is seccomp BPF? BPF is a VM, and it's a mini VM. It's actually not exactly a fully emulated CPU. You can't run loops in it, for example, but you can compile instructions and run them, evaluate them in like an arbitrary set of rules, and evaluate them inside of the BPF VM in the Linux kernel. This has been applied in the past to packet filtering, which is what it was invented for. Like how do you support an arbitrary number of packet filters? BPF was a very elegant and like a very neat answer to that problem, a very neat solution. So this has also been applied to filtering system calls. So the kernel allows a process to install a seccomp BPF filter that can do different things when specific system calls are invoked. You can use this facility to greatly reduce the exposed attack surface on a per process basis. And as a result of that, you can prevent privilege escalation through system call vulnerabilities by not having those system calls available for processes that might try to exploit them. So we have done a lot of work on making this very fine-grained and very easy to do for like for desktop Linux, I guess. So I wrote a profiler that runs any process and captures the system call invocations, including parameters, and outputs a policy that looks like this. So I wrote the original version, then we collaborated on it. But yeah, this is the output from our system call runtime profiler, and that is a compilable seccomp BPF policy using the BPF compiler that we have. As you can see, it looks like C, right? Like it's each line you can write expressions that have like constants in them. You can do evaluations that are kind of C style. You can do bit masks, things like that. So this is something that's unique to our project that we put some effort into. It also does things like the output when you run the profiler orders the system calls by frequency. So the most frequent system calls are first, and this actually makes, for like a desktop application that's like graphical and interactive, this makes a perceptible difference in performance. So a quick primer on seccomp and seccomp BPF. When a match is made by the BPF policy filter evaluator, you can do these things. You can just tell the kernel to just kill the process. You can tell the kernel to notify an attached tracer. That's how our profiler works, by the way. It uses ptrace. Or you can do that and do it in such a way you can actually bind the tracer to the process, such that if the tracer exits, the process killed. That's an interesting feature I'd like to explore in the future, to do kind of more advanced hooking based on BPF hits, but we're not using that. We are using that, but we're not taking full advantage of what we think might be possible yet. So what does this mean for us? So Firefox is a pretty complex application. It's the basis of Tor browser, for example. We found that Firefox required 145 syscalls out of 330. Thunderbird, 138. You can see it's a substantial reduction in available code paths. And a lot of the system calls are really the same across all applications. So I talked about the complex system calls like, I don't know, futex or ioctl or fcontrol or setsoc-opt. Our profiler will capture the parameters, so we further constrain. We might allow the socket system call, but we only allow Unix domain sockets or only IPv4 sockets or something, or setsoc-opt, this culprit system call. We only allow this system call to be used in the very specific way that we saw the process using it, and that's enforced. So if the process goes wayward and tries to call it another way, it will get killed by the kernel. It will be logged, and actually you would see that little pop-up that you saw. So one of the things we were worried about when we did this was we were like, how stable is this? Are we going to be able to ship policies that work for more than a week? Because these are system calls. They're abstracted away from the developers of the program. So as glibc changes, which is where the system calls are actually called directly most of the time, how often does glibc? We didn't know. I didn't know before we started doing this. We found that they're surprisingly stable. And we also had interesting things happen. I'll give you one example that's memorable. There's a developer who works at Red Hat, and I think he's one of like the primary SE Linux developers, introduced something into like libSE-Linux, which is linked to like every single user line binary for some reason in modern Linux distros. This developer, I don't want to blame the wrong person here, but I think it was this person. This person like introduced into libSE-Linux in the initialization code an attempt to mount /proc everywhere by every process. Most of the time, this fails silently, and the failure doesn't cause the program to terminate because it's not a fatal failure for the library, and there's no error output. It just quietly tries to like mount procfs, and because most processes are unprivileged, this fails. But for us, because we had extremely tight seccomp BPF policies, every single program in Subgraph OS that was seccomped was getting killed because they were all trying to call the mount system call. So we're like, this happened suddenly one day, and we're like, whoa, what's going on? And we look and we see like every process is like calling the mount system call and trying to mount a procfs. And we tracked it down, and we found out that this was a bug that was introduced that like nobody else noticed. We didn't notice it first. It had already been found and addressed, but I mean, it wasn't perceptibly noticed by anybody as abnormal behavior of a process. But we were able to catch it, and that's exactly what this was designed to do. So our sandbox offers complex networking capability, increasingly complex networking capability. So as a sandbox, which can be configured, and the parameters are in a JSON file. You can tell it no networking. You can forward ports from inside the sandbox, ports that are bound. You can create listeners that are bound to localhost, and those can be forwarded to like arbitrary ports. So one thing we do with this is we create, like for like the Tor browser sandbox, we create a Tor and Tor control port forwarder inside the sandbox that look to Tor browser like Tor, but they just forward to Tor outside. Actually, now they forward to our firewall, which I'll get to. But we can do that with like I2P. We can do that with an SSH SOCKS 5 port, although DNS, you have to figure out DNS inside a sandbox in that case. But yeah, so we can do these sorts of things. We can create an ETH, like a virtual ETH0 inside the sandbox and attach it to a bridge, and that's how we implement our ClearNet sandbox. And we can do the same thing with OpenVPN and WireGuard algo. In the future, we will be probably putting optionally TUN and WireGuard devices right in the sandbox, because you can just set NS, you can set namespace for those kinds of devices, and they will remember their previous connections, which were made in the outside namespace, which is kind of to create kind of a wormhole. It's kind of a neat feature that exists for those two devices. We could, I don't know, do GRE inside the sandbox. We could do a lot of things. It's really neat. Today, the way we implement bridge, we implement, like the way we do the routing for OpenVPN is when you launch an OpenVPN sandbox, the TUN device gets created outside of the sandbox, and then the bridge, the ETH0 inside the sandbox, gets like we do dynamic policy routing. We create another routing table just for that sandbox, and then we create routes that like send it all through the TUN device. That's how it works today. It doesn't need to work like that, but that was done so that multiple sandboxes can share the same VPN. GPG is something I thought I would throw in here if anyone is using PGP, like PGP for email. Our mail client sandbox doesn't have any private keys. What it does is we put the GPG socket, the restricted socket, into the sandbox, and when GPG starts, it goes looking for that, and it actually talks through that, and then the private keys can stay outside. Or if you're using like a smart card or something, like or whatever, the YubiKey that supports PGP, we just natively support that because GPG agent will forward the protocol request through that socket. So it just works. We didn't have to implement anything ourselves for that, which is kind of neat. When pin entry launches and you type your password, that password, those bytes don't go into the sandbox. So what happens is like you ask the agent, I want to decrypt this, or I want to sign this. The request goes through the socket, and then on the other side, outside of the sandbox, pin entry gets launched, and you type your password. So that's kind of neat. I didn't have time to finish implementing this for 44Con. I kind of ran out of time. But we have support for devices, like USB devices inside sandboxes, like YubiKeys, for example, or hardware wallets for cryptocurrency. The way it works is so sandboxes subscribe to a device. So we will create profiles for YubiKeys and hardware wallets, and those will have like the major minor numbers of those devices and some other meta information. And when UDEV sees the device being inserted, it will notify the sandbox that, hey, this device is here. Please attach it to any sandboxes that subscribe. And then the sandbox will go in and create the devices, and then they won't be able to create any other devices because we will use whitelisted device C groups. That's a facility in the Linux kernel to limit for a process what devices can be accessed or created. So we have this working in like ugly prototype, but it's not available in any way for anybody yet. I didn't have time to finish it. Yeah, we use AppArmor for our own stuff. This is, again, not that exciting because like other distro like Fedora, Ubuntu use AppArmor extensively, and it's effective, actually. AppArmor is good for lots of things. We find it breaking things we want to do, and that means it works. So we use it where we can. Yeah, the firewall. So the firewall is based on NetFilterQ. NetFilterQ is a Linux kernel, another interesting Linux kernel feature that allows you to tell the kernel to send packets of some kind back to userland. And then it's up to the userland program to return with a verdict for the packets that come in from the queue, whether there's a few different verdict options, like, okay, let this one pass, or drop it, or et cetera. So we use that feature to implement a userland firewall daemon, including a UI component written in GNOME shell, which is why it looks so nice. We learned how to program GNOME shell. It's JavaScript. But the daemon itself is in Golang. And it does stuff like it caches DNS requests and saves them so they can be presented, with the dialog. We can filter on destination, ports, protocol, UID, GID, et cetera. You can create policies that remain forever, or that just are there for the life of your session, or are there for the life of the process, or even one-time decisions. So it's something like Little Snitch. This is a real example. So this is another thing we found while we were working on Subgraph OS, while we were working on the firewall. We found that GNOME calculator, like we were just testing and someone opened calculator and suddenly the firewall popped up. And we're like, what? The reason why GNOME calculator tries to quietly, without any indication to the user, tries to make connections to the IMF is because it has a currency conversion feature. So every 24 hours, it's trying to get like the latest. It makes two connections, one to the IMF, one to the European Central Bank. But you don't know that unless you have something like this. Pardon me? Oh, yeah, yeah. They don't tell you that. Like, they don't tell you. There's no option. It's the default behavior. But we found it because they got mad at us, or some of the GNOME developers got mad at us for making fun of them about this. But, I mean, they should fix it. So one of the things we've done recently, and it's taken us a while to get to the point where we can release this. We're getting there. We're very close. You could try it. We have packages that you can install, but it's not yet robust enough to include with the default ISO. Our sandbox now has, our firewall now has sandbox awareness. So when you get a pop-up, it will tell you which sandbox the traffic was coming from. And it will also indicate to you that it was sandbox traffic. What you also see in this example is that so in this example, HexChat is configured to use Tor. Okay, so inside the HexChat sandbox, all there is a port that exposes the Tor SOX5 interface, or what the application thinks is that, and then that's there for the application to connect out. So you see that it's like via SOX 5 Tor, if you can see underneath where it says Sandbox. But one really cool feature we added is something called TLS Guard. TLS Guard is for people who hate the idea of using something like Tor or anything without TLS because of the risk of exit nodes either observing traffic or interfering with it in some malicious way. So what is TLS Guard? So TLS Guard is mandatory enforcement of TLS over any port without active TLS interception. So we're not breaking TLS. What we do, and this is only in Subgraph Firewall, is we observe the TLS handshake. And first of all, if there's no like magic byte that says this is TLS, we drop it immediately if that's the policy. And further, the firewall daemon continues to observe the handshake and grabs the server certificate and validates it independently of the application. Because some applications maybe don't do a good job of validating certificates. Who knows? But we want to make this mandatory, so we put it outside of the app. That's one nice thing we can do about Sandboxes. We can control many dimensions of how they run, and we can do this quietly. It doesn't mess up the application. We haven't done this yet, but we can, if we see invalid certificates, we can save them, or we can implement trust on first use outside of any app, right? So we can say, okay, take the first certificate you see, save it. If that certificate changes and the previous one you saw didn't expire, tell the user that happened. That's interesting, okay? Give the user, we can do things like that. And we can do it independently of the application. So very, very security smart applications, like Chrome is the best example of an application that's built like a fortress. I mean, they have pinning, they have all kinds of like defenses against the user and against the user who doesn't know better, and the operating system and everything. So I mean, but random apps like HexChat don't have this stuff, right? They don't have pinning. We can do pinning for your certificate. So if any other certificate is seen, doesn't matter if it's valid or not, we can kill the connection and alert the user. Unfortunately, TLS 1.3 means no more clear text handshake, and that's coming. So we're going to lose, at least we think for now, some ability to do some of these things. But we will still be able to detect if it's TLS or not in the first place for any application over any port, and still still enforce mandatory TLS. We just may not be able to do, at least not passively, we will not be able to do this kind of certificate stuff that we do. But it's going to be a while before random apps the browsers will support TLS 1.3. They already do. But like random apps won't for a long time, so we can still benefit from some of these neat features. So we're not really we're moving away from being Tor-centric, but if you have to use Tor, or if you're going to use Tor, you should do it right. So when we do things like we filter access to the control port. So it's probable some of you don't know what that is, but Tor has a port that it opens. It can also be a Unix domain socket, which we configure. But that allows you to do different things. Like you can tell it to use a bridge, or you can tell it to, I don't know. You can control how Tor runs. So we filter access to that. So random apps can't just query the control port for random information. But we also do things like intercept onion server requests and then rewrite them and route them into Sandboxes. If any of you have used something like Ricochet, it's like a chat client, a decentralized chat client. It allows people to chat over onion services that are ephemeral. So rather than setting up like onion servers in your host file system, we intercept those and then reroute them and send incoming connections from Tor into Sandboxes. I hope you understood that. If not, it's not a big part of what we do, but it's just like one of the little things we do to make certain apps for Tor safer to use, because we think Tor is kind of scary, actually. Another thing we added recently is a filter for Tor. So in the future, how you use Tor is going to be very controlled. So every process that's trying to talk to that SOX 5 port is going to have to go through the firewall. whether it's coming from a sandbox or whether it's coming from outside. The only way to get to Tor will be to hit, so I have it running like this on this computer, but it's not the way we ship it now. Basically, there's no more Tor 9050 port bound to localhost that anything can connect to. Tor SOCKS 5 interface is actually a Unix domain socket that has restricted file system permissions somewhere on the file system. And the only thing that will forward you to that that's exposed to all processes is the firewall, which sets up its own SOCKS 5 port. So your apps connect to that, and then they're either permitted by policy, or you get a pop-up where they're dropped, and then they get sent back on their way out to wherever on Tor. So again, if you're going to use this thing, Tor, you should do it in a safe way, and this is something we're trying to build support for. You've already met the event notifier. This is just a way to alert to the user that things happen. And security people want to know if PACs killed a process on their system somewhere. I want to know about that. If something was killed by seccomp, we want to know about it. Things like that. If things were denied by the firewall, maybe you want to know about that. So we have this monitor for events. Okay, so this is kind of more of the same. This is a strategic goal we have. I can't claim we accomplished this today, but it's an interesting idea that we want to build a system that somebody attacking would be worried about, where they would be worried about losing their exploit. I think attackers have taken for granted, maybe less today, because there's more defense companies that are trying to capture more information about things that happen on systems and in networks. But in the past, there was a good chance if you had an exploit and you deployed it against a target, if it was successful or even if it failed, they would never know, even if it failed. So how am I doing for time? Okay, I have 10 minutes, so I'll try to wrap this up for questions. Yeah, so we would like to build a system where every attacker has to think twice, because we record events, we collect forensic data actively, and we try to change their deployment calculus, and so they have to factor in the cost of losing an exploit or a backdoor. This is a future strategic idea. So yeah, I talked about many of these things. This is what we're working on in the future. We have big stuff that's going to be a big surprise that I'm not going to mention here, but that's coming in the future. It's a long-term project for us. So quick demo. So this PDF viewer I was running is running in a sandbox. Oh, my torrent is complete. I wanted to show you that. So I can show you. So this is me listing the sandboxes I'm running. So I run Oz list. So I'm running Chromium VPN. This is a browser that is running in an isolated sandbox, and it has an exclusive connection coming out of Turkey. So this is the little website I set up for demos. So I can also run just regular Chromium. It should open up in a second. Okay, so if I check my IP address, I'm coming from the United Kingdom. I can open HexChat, which will go through Tor once it starts. Okay, so if I connect to LinkNet, I get a notification that the certificate is not valid, and that's because I had already created a policy in our firewall. So our firewall killed that. So I'll try to connect to another server, 2600. I think that one I have no policy for. Okay, so I'm trying to connect to the 2600 IRC network. So there's the pop-up. I can say, okay, yes, connect, but require TLS. Allow. Oh, okay. Anyways, the certificate's bad, and I think the firewall is going to not display another notification for that. So, anyways, so if I connect to one that actually gives you a good certificate, like OFTC, So this is like sandboxed, going through Tor, and firewalled. It should succeed. Yeah, there we go. So I can connect to channel. So this is our IRC. Oops, no, I spelled it wrong. Yeah, there. That's our IRC channel. Yeah. So, what else can I show you? Yeah, I think that's pretty much it. You've seen the firewall. You've seen different profiles. If I go into I have a torrent. I have a BitTorrent. I have a BitTorrent client that I just downloaded, Swamp Women, which is in the public domain apparently, and I downloaded that from here. 5. So now I'm in the shell. I can just run this little script I made called Where Am I? That queries OpenDNS for my exit IP and then geolocates it. So if I run this program, it tells me I am exiting from Brazil. It's supposed to show a flag. There we go. So I'm exiting from Brazil. So that is Subgraph OS. And I can also watch videos just fine inside a sandbox. So I'll just turn on the audio now and watch some Turkish Star Wars. This is also apparently in the public domain. I'm not sure it is, though. Yeah. So the video quality is not Subgraph OS. It's yeah. Yeah, it's man who saves the world. Yeah. No, that's it. Yeah. So that's our project. If you guys are interested, a lot of things I showed you are still, we're under heavy development right now. And so some things are kind of broken. Some things I showed you are not available. But yeah, lots of things are under development. Oh, one more thing I guess I can show you. The USB thing. If I lock my screen, if I enter, so I lock my screen and enter. I put in a USB stick and then pull it out and then unlock my screen. I should have a warning about that. It should appear. There's the event monitor, the log system is kind of wonky right now, unfortunately. So demos are always supposed to fail. Sorry, but it should have been prevented. Or maybe I wasn't running it. Okay, anyways, I'm not sure why it didn't show up, but yeah, we have a monitor that's supposed to be running right now that checks to see if the screen is locked, and if it is, it enables a GR security feature to deny any new USB device. But that failed, but you can still watch Turkish Star Wars, I guess. That works. So we have a few minutes left for questions. I have a workshop that I offered to do this evening. I don't have any official program for that, and because our project is like an operating system, I don't expect anybody to have it. So what I can do is I can walk through setting up a VPN for an application. I can walk through seccomping, like analyzing a process with seccomp and tweaking the policy. And things like that, things that you can do, and I can show features, I can talk about things. So that's what we'll do in the workshop. If anyone wants to join tonight, I'd be happy to talk about any of these things in detail. So any questions?